Ladies and gentlemen of the jury, I present to you the case of the location of accretion. The location of accretion in astrophysics. Here I have, taken directly from a very well-sourced internet article from Wikipedia on accretion. Quote, in astrophysics, accretion is the growth of particles into a massive object by gravitationally attracting more matter, typically gaseous matter, in an accretion disk. Look for those key words. I'm going to break it down. Question number 1. Do particles clump together by themselves, or is it an already present gravitational well needed? That is the main question. Therefore, we should outline where the problems would be lying and if we have better solutions to solve this problem. Do they clump together by themselves, or do they need something already present? I'm going with, to clump particles and anything together in outer space, you need something already present to cause the accretion. My reasoning is as follows. How strong is the gravitational well of the sun? Very, very strong. It can hold the Earth, Mercury, Mars, Jupiter, Saturn, Neptune, Uranus, and every single asteroid in the entire solar system gravitationally bounds itself to the sun. That's a pretty badass gravitational well, if you ask me. Now, what's the gravitational well of a large asteroid? Probably not that much. Probably very tiny. Almost non-existent. I'm pretty sure if I could stand on a large asteroid, depending on how big it was, I could probably jump up off the asteroid and leave its gravitational well. That's bad news if you're going to have particles clump together that way, because what would happen is the particle will hit the object, and it doesn't even need to go that fast. Maybe like 6 or 7 miles an hour, and it will leave the gravitational field of the large asteroid. Now, if I were to go towards the sun, I would be proverbially the F word, ED. Alright, which one would collect the most matter, accrete more, the sun or a large asteroid? I'm pretty sure the sun would accrete more because, well, it's freaking huge and its gravitational well is freaking massive and it's traveling through outer space at what, 74,000 meters a second or something like that? And it's just sucking in matter as it goes. Now what about a large asteroid? How much matter do you think a large asteroid would be able to accrete? Probably very, 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 very little, because it's so tiny compared to the sun. If you put the sun next to a large asteroid, you probably wouldn't even be able to see the large asteroid. This object is way, 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 way more massive than this. So yes, the sun probably accretes way more matter than a large asteroid would. Next question. Which one has the most surface area to collect more material? That's a no-brainer. The sun's surface area, well, hell, you can do some math. Its surface area is many thousands of times greater than the Earth itself. And a large asteroid is many tens of thousands less than the Earth. Meaning the sun is many, 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 many magnitudes greater in surface area. So as it's going through outer space, it can hit more matter, it can suck in more matter, it can accrete more material, and it can trap it because its gravitational well is so strong that the matter cannot escape. An asteroid, on the other hand, if it's traveling through outer space, it's so small, and its gravitational well is so weak, whatever it hits, it can't collect it. It just bounces right off of it. You cannot accrete very well with an asteroid. Next question. Which one can vaporize, ionize, and melt the interstellar material the best? The sun or a large asteroid? Well, in order to have material accrete or become ionized or vaporized, as in the gaseous matter, you need some mechanism to heat it up. Now, how hot is the sun? Pretty freaking hot. It can almost ionize any element out there, as well as it'll vaporize everything that ever gets close to it. If an asteroid's lucky, it can skim the surface. But compared to a large asteroid, can a large asteroid melt and vaporize and ionize material at the extreme rate that the sun can do? I don't think so. It can't touch the sun. The sun is way more badass than a large asteroid when it comes to melting, vaporizing, and ionizing interstellar material to allow for the accretion process to occur. Next, which object can absorb the largest objects, the sun or a large asteroid? The sun can swallow large asteroids, but I've never seen a large asteroid absorb a sun. There you go. The sun wins again. So now we have the sun 5, large asteroids 0. And last but not least, going back to the original statement, do accretion disks have gravitational wells? Or is the only gravity well the central object, meaning the star itself? Well, scientists want you to believe that accretion disks have gravitational fields. That is very, very false. The only gravitational field that exists is the central object, meaning it is the star itself doing the accretion, meaning the disk is more than likely completely irrelevant towards whatever the star is doing in the center. This just happens to be something floating around that just happens to be there. It doesn't have anything of value when it comes to the accretion process itself, even though it's actually physically there. So that all amounts to the incorrect interpretation of what a disk actually is doing. So, hopefully this lines it all down, how the sun completely destroys any kind of large asteroid doing the accretion. We can make a clear conclusion. The conclusion: accretion happens inside of stars, not via particles or large asteroids or whatever in outer space. Now, we know they happen inside of large stars because the stars have all the properties needed to accrete the most material, to ionize the material, to heat the material, to trap the material from its huge gravitational field. Stars are the places where matter is collected, meaning as the star collects the material, it forms the planet in its interior, and it accretes the planet inside of it. That's what it does. And then when it starts dying and cooling down, the outer atmosphere dissipates away, revealing the little kernel of what's called a planet in the center. And this process happens over many billions of years. So, accretion. Hopefully people can really get this. I think it's common sense. Maybe it's a really good natural philosophy. I'm not too sure. But the idea that matter accretes outside of a star is absolutely bogus. The star is the location for the accretion process. meaning stellar evolution is the process of planet formation itself. Later.